Hi everyone, we're not here today. I am Mr. Robert.
And I'm Mr. Hamill.
But even though we're not here, we are here. We are here to teach you your lesson through the magic of the 21st century.
Ooh.
So, you've had exactly 5 minutes to finish your warm-up. Mr. Hamill.
So your first warm-up question said, if 11 is a factor of 319, what is another factor of 319? If you remember, a factor of a number means that when you divide it, you get a remainder of 0. So we would say 11 is a factor of 319 because when you do the division, we end up getting a remainder of 0. So 11 is a factor of 319 because we get a 0. As a result of doing this division, you also get another factor of 319. What would that other factor be? Yes, perfect. It actually is 29. The other factor of 319 would be 29. So we would say that 11 and 29 are both factors of 319. Mr. Robert?
Awesome. So what we just learned is that factors and division have something to do with each other. In fact, if we get this remainder of 0, we say these are factors of that. This, you had to use synthetic division, a new skill from yesterday. So let's set this up. We're dividing by x plus 2. So in our box we have -2. And now we're going to list all of our coefficients. 3, -4, -28, and -16. Draw a line, and hopefully this is what you got. 3 times -2, 6. Interesting. We got a 0 here, meaning our remainder is 0. I mean, we could write 0 over x plus 2, but that seems a little silly right now. Let's connect this 0 to this 0. Here we had 11 times 29 equals 319. What we just found is that x plus 2 times, let's look at what we have here, x plus 2 times 3x squared minus 10x minus 8 equals our original polynomial. So what we're going to do today is use something called the factor theorem, which allows us to use division to help us factor things like this. What we just found actually is that we could factor this as the product of these two. There you go.
So, right now we're going to give you about a minute and a half to pull out a piece of paper. You already have paper out. I apologize. On the paper you're working with, we're now going to start the notes for today.
And I know my class is just as awesome as Mr. Hamill's, and they have paper out and they're ready to take the notes as well. So even though you're just as awesome, let's go ahead and give you that minute. Can you get out a piece of paper and be ready to take the notes? Because I'll be checking these with your homework assignment on Monday.
Get them out now. I'm almost ready. You have them out?
So you only have like 10 more seconds to get those notes out.
All right. So we're going to get started. If you check your flower sheets for Mr. Robert's class, or flower sheets for my class.
You have flower sheets.
I have flower sheets. Flower sheets for my class, or the fish sheets for Robert's class, We're going to pull problems straight off of your homework tonight. So this will be straight from the book. So we're going to start with number 22.
And so we're in the same section. This is 5.5?
Yep.
5.5, part 2, notes and homework.
So if you look at number 22, let's just write down the problem first, and then we'll go over what the directions say. 22 says f of x equals x to the third power plus 6x squared plus 5x minus 12, semicolon x plus 4. So let's see what the directions are saying. The directions are saying given a polynomial and one of its factors, factor the polynomial completely. So we need to write this polynomial in completely factored form. Now, if one of the factors is x plus 4...
Wait one second. Hey, write that down. He's going to talk about it. Come on. Okay, I'm sorry. Go ahead.
Thank you, Mr. Roper. If we need to know one of the factors, if you remember, just like in our warm-up, we had 11 was a factor of 319. And when we knew 11 was a factor, we just divided to get the other factor. We're going to do the same thing. We know x plus 4 is a factor. So what I'm going to do to factor this is take my original polynomial, and I'm going to divide it by x plus 4. Now, remember from yesterday's lessons, you have two options. You can use long division or synthetic division. I'm going to use synthetic division to do this division. So, if I'm dividing by x plus 4, I'm going to be putting negative 4 in the box. I then write down all of my coefficients. 1 for the x cubed, 6 for the x squared, 5 for the x, negative 12 for the constant. Now I'm going to pause to make sure you have this written down. Good. Notice you bring down the 1. 1 times negative 4 gives us negative 4. 6 plus negative 4 is 2. 2 times negative 4 is negative 8. 5 plus negative 8 is negative 3. Negative 3 times negative 4 gives us positive 12, and we get a remainder of 0. This remainder should not be a surprise to you. They told us this was a factor. Remember, to be a factor of a polynomial, you should have a remainder of 0. So let's write down what this actually tells us as a polynomial. Notice this will become a trinomial, with the constant being negative 3, the linear term being 2x, and the quadratic term being 1x squared. Now, if you really want to write the one, you can, but it's more proper to leave it off. So, notice when we took our original polynomial, divided by x plus 4, we got this as an answer. So that tells me I can take my original polynomial, x cubed plus 6x squared plus 5x minus 12, and write it as a product of its factors. So, x plus 4 times x squared plus 2x minus 3. Just like in the warm-up, when 11 times 29 gave us 319, we have a similar result here. But when you look at this answer, you have to remember the direction said factor completely. We definitely have started to factor, but are we finished? Oh, what are we supposed to do then? Oh, yeah, guess and test, or X, or whatever method you're using out there, yeah. This polynomial here can be factored further. So I'm going to take this polynomial, I'm a fan of the guess and test method, and I've become an expert at it, so x times x gives me x squared. Positive 3 times negative 1 gives me negative 3. And 3x minus 1x gives me positive 2x. We have all linear factors here, so this is considered completely factored. Are there any questions for me? I can't answer them, I'm sorry.
I kind of have a question. Can we just go through this once again? So on the homework, we're given something like this. Can you kind of walk me through it once again now that we've done all the work?
Sure, I'd be glad to. So you're given the problem like this. You're given a factor in the polynomial. So you need to divide to find the other factor. We use synthetic division of this factor to end up getting the next factor. So the synthetic division gives us this next factor. So we rewrite the original polynomial as the given factor times the new factor we found. Once we write that product together, we then ask ourselves, are we done factoring? And when you look at this factor here, you'll notice we're not done factoring, so we factor one more time to get the final answer.
So all we're really doing is trying to factor this entire thing. And we're given a hint. We're given one of the factors. We use our hint to figure out what the other factor is, and then we noticed that factor can be factored further. That was a lot of F words. Let's look at another example. Give me a second to copy this down.
Quickly, it's going to go away soon.
Now, if you're a little confused, it's okay. That's why we're doing more examples right now. So have a little bit of patience. We'll try another example. And at the end, you have a wonderful substitute with you today. I think he's sitting right over there in my class. Where's he sitting in your class?
I think he'll be sitting over there in mine too. Hi, Mr. Warner.
Hello. I haven't assigned you yet, but I know my kids love you. So.
If you didn't finish copying it down while he's writing the next problem, go ahead and turn to a neighbor and try to get the work off of them.
The next problem we're going to do is number 28. Number 28 has the same instructions as number 22. Is this a 6x or a 61x? Check in your books right now. Let's see. Is that a 6x or a 61? I can't read my writing.
61x.
Oh, it's a 61x. Okay, cool. Thank you. So once again, our job here is to factor this polynomial completely, but we're given a hint. We're given the hint that x minus 5 is one of the factors. So to actually utilize our hint, we need to divide this polynomial by x minus 5 to figure out what the other factor is. I'm going to use synthetic substitution again. But as Mr. Hamill said, you're welcome to use, or I'm going to use synthetic division again. But you are welcome to use long division if you want. I put the 5 in the box, write my coefficients. So now I'm all set up. So I'm going to do this pretty slow. See if you can race and beat me right now. So 3 times 5 is 15. Negative 2 plus 15, that's negative 13. No, that's positive 13. Good thing I was doing it slow and caught my mistake. 13 times 5. I don't know. 10 times 5 is 50 plus, oh, 65, all right. Negative 61 plus 65, 4. Okay. 4 times 5?
0.
Yeah, got a 0 again. That's good. That means my hint actually worked. So, using this factor and this information right here, I now know I can factor 3x cubed minus, so I'm just rewriting the original polynomial. This can be factored as x minus 5 times, well, I just saw Mr. Hamill do this backwards, and I kind of like that. So we'll have 4, 13x, and 3x squared. So 3x squared. 13x is our linear term, and our constant term is 4. All right, cool. So now the question is, have I factored completely? I don't know. Kind of have to look at this for a while. So go ahead and look at this. Look at this. Look at the other people in your class. See if anyone can figure out how to factor this. I got it ready to factor. Did anyone factor it?
Three x plus 1.
Oh, thank you. So that would mean the other term is, think about that. Oh. So let's test this. Let's see if we get this 13 in the middle. 3x times 4 would be 12x, and 1 times x would be x. So there's our 13x. Now we have factored completely. I think I have time to show you one more thing. What if instead of telling us to factor completely, this problem actually wanted us to solve? So let's change the original problem. Instead of saying f of x equals that and factor, let's say we were supposed to solve when this equals 0. Well, if this right here can be factored as this, we can use the zero product property, because we know that this equals 0. Meaning that this, or this factor has to equal 0. Yes, Mr. Hamill. Oh, 1 minute left? 1 minute left in our recording, not in your class time. Hey, stop packing up! All right, let's figure out what we do here. If this factor were to equal 0, x minus 5 equals 0, well, x must be 5. This is the only hard one. 3x plus 1 equals 0. Move the 1 to the other side. Looks like x equals negative 1/3. Oh, question about how we got negative 1/3? Right now, I'm giving you until the bell rings in here, which is 22 seconds. Talk to someone, figure out how we got these 3 solutions. 15 seconds. Wait, no, seriously, talk. You only have like 6 seconds. Sit down, that wasn't your bell. Okay, we'll continue in a minute.